So now in this video, we are going to do the regression analysis and we will do the basic model. Remember that for this exercise, we have the assumption or the model where we have 4 different types of control and we want to measure if its impact on performance. So it's basically 4 hypotheses with 4 variables. The first variable is the belief systems with performance, then boundary system with performance, interactive with performance, and diagnostic with performance. So it's basically direct effects of these 4 variables. And what we are going to do is to go to analyze and then regression and then linear. And in here, well, I already have something from because I already did it, but let me just clean this up so I can show you step by step. So basically, what you have to put on the dependent is your y variable. So the dependent variable in this model is performance because we want to check if different types of control affect performance. So we will start with performance. In here, it is performance. Remember performance as this variable is the average of our 6 questions because performance is kind of made with 6 questions. In the previous video, we realized that we could put them all together because the Cronbach alpha was quite high. So we have performance. And then for the, in here, in this part is where you add your independent variables. And the independent variables for us are going to be, I always like to start with the X, the variables that I care. So it is uncertainty, beliefs, boundaries, diagnostics, and interactive controls. Sorry, the important variables are the controls. So belief systems, boundaries, diagnostic, and interactive. For this specific model, I want to test all the 4 different controls all together because that's kind of the theoretical assumption that they work at the same time. There might be other cases where you want to isolate this and maybe you just want to test belief systems against performance, and that's okay. It depends on how you design your study. But for this, we are going to use to do the 4 at the same time because they work together kind of. And then we're going to add all the control variables. And for those control variables, we have gender, age, education level, position in the company, expertise, experience, size of the company, and uncertainty. Uncertainty will become very relevant in the next test in the moderation effect, but for now, we can use it as control. So I just select all of them and I put them in here. And as you can see, they all come in here. The other thing that I recommend you to do is to go in statistics and click on collinearity diagnostics because multicollinearity is very important in these regressions that we are doing. We want to check if there is no collinearity between the variables, like if we are not kind of if we are not measuring the same thing twice, right? Imagine that you are asking for age and year of birthday. It's basically the same thing. So if you have that problem, you will have a very high multicollinearity between both. So I will click OK. Then this comes up. So pay attention to this, which is the interpretation of the regression model. So first, we need to check the significance of the model if there is model if the model fits. So to do that, it's super easy. We just need to check the model summary. It's in here. And we get we need to go directly to the ANOVA, and we need to check the significance of the ANOVA here in regression. So we always we tend to say that something that is below 0.1 is okay, so 0.09 is okay, 0.05 is okay, and this is great because we have less than 0.001. That means that our model fit is very good. So we passed the first issue, the issue with the model fit. So we can move on. The next point is to check if there is no multicollinearity. So to do that, we need to check the BIF values, which is this. So again, we usually tend to say that something below 4 is okay. So if nothing is higher than 4 is okay. And if none of the numbers are higher than 2 is excellent. So in our case, we have excellence for multicollinearity. That's great. So we passed 2 tests, the model fit and the multicollinearity. And then we just need to now interpret each of the variables, especially the ones that we care about, because with that, we will reject or support our hypothesis. So we can quickly take a look at the controls, but they don't really matter. Like, for example, it seems that from the controls, position is important. Like, that's very strange. Like, the higher the position of the respondent, the better performance. It's kind of strange. And all the other controls are not significant, but that doesn't matter, because remember that for our the purpose of the controls is to improve the model, like, so the model fit is better, and also to increase the adjusted R-square, which means like how much percentage of the variance of the performance is indicated with this regression. 0.25 is still okay. We also say that in business administration, we are okay with having something higher than 0.1, for example, 0.15. And we don't like perfect models, because perfect models are more like for engineering or for something that's not social. So we are okay with something below, I don't know, 0.9, 0.8, something like that. We don't like perfect models. So this is fine, 0.25. So remember, the controls are not that important. But these are the very important variables. So we need to check the significance if the significance is lower than 0.1. So from these four, it seems that the one that is very good is interactive controls. It seems that interactive controls have a positive relationship because the standardized coefficient is positive, and also the unstandardized is positive. And it is significant because it's lower than 0.1. Then we have the diagnostic controls. They are also positive and significant, a little bit less significant than this one. So it's actually kind of in the borderline, but it's still significant. And this one, belief systems are okay. The only one that is not significant is boundary system. So it seems that in this sample, because the model fits, because we don't have multicollinearity, because the R-square is fine, we can conclude that boundary system don't have a relationship with performance, but the other three do have, just in our sample. And because of that, we'll have to reject one hypothesis and support the other three. But then the interesting thing is, how do you connect that to the theory? Like, why does this happen? So far, I think the model is nice. It's nice that it doesn't have multicollinearity. It's also interesting that it's not perfect. Like, not everything is perfect. And then for controls, we don't really care. So that is the normal model. In the next video, we are going to do a moderation effect model, which I think is interesting and relevant for this study.